In the starting of the wave shaping circuits, we have discussed wave shaping circuits are two types: linear wave shaping circuits and non-linear wave shaping circuits. We have already discussed about the linear wave shaping circuits, RC differentiator and RC integrator. For those linear wave shaping circuits, we should not give input as a sinusoidal because we do not understand what the circuit is doing. The signal shape is not changing. So we have given the square wave as input, and the differentiator gave the spikes as output, and the integrator gave triangular signal. Now we are trying to discuss about the non-linear wave shaping circuits. The first one is clipper, and later we will discuss about the clamper. Clipper is a non-linear wave shaping circuit. So it clips the signal. So it clips the voltage of the signal after a certain level. We are limiting the voltage of the signal. The signal's amplitude is in our control. Whatever we are deciding the amplitude should be, the signal amplitude will be cut to according to that. This is what we call as clipping. Now we are trying to classify the clippers. The classification, first we are discussing based on the clipping level. Based on the clipping level. Positive clippers, negative clippers and double-end clippers. If the clipping is in positive portion of the signal, the positive peak is clipped, then that type of signal and there is no change in the negative waveform. That type of signal is called as, that type of wave shaping circuit is called as, that type of non-linear wave shaping circuit is called as positive clipper. If there is no change in the positive peak of the input signal and the negative peak is clipped, that type of the non-linear wave shaping circuit is called as negative clipper. If both peaks are clipped, then that type of non-linear wave shaping circuit is called as, that type of clipper is called as double-ended clipper. So based on level, positive clipper, negative clipper and double-ended clipper. And based on the components used, whether we are using a diode for the clipping, then that is called as a diode clipper. If we are using a transistor for clipping, then that is called as a transistor clipper. If we are using op-amp for clipping, then that is called as op-amp clipper. And the next one is in what configuration we are connecting this clipping element. Configuration. In the first year you might have studied in what configuration the transistor is being connected. Based on that we are dividing common emitter, common base and common collector. Transistor is single, but we are connecting the single transistor in different configurations. The same transistor can be connected as a common emitter or common base or common collector, depending upon our requirement. So here similarly, we are connecting, if we are connecting the diode in series with the resistor, then this type of clipper is called as series clipper. If we are connecting the diode in shunt with the load resistor, then it is called as shunt clipper based on the configuration. And then we are trying to understand the clipper. We want the clipper, fixed clipper or variable clipper. We want, if we have the flexibility to change the clipping voltage, if I am capable of changing this clipping voltage, then that is called as variable clipper or adjustable clipper. If the clipping level is fixed, then that is called as fixed clipper. So based on the control of clipping level, fixed clipper and adjustable clipper. If we are using an external supply to decide this clipping level, then that is called as biased clipper. So based on the external reference voltage. The clippers are divided into two types, biased and unbiased clippers. In unbiased clippers, we are not adding any external supply to the diode. External supply will not decide the clipping level. In the biased clipper, we are intentionally adding the external supply along with our input. So this external supply will decide the clipping level. In unbiased clippers, only diode itself will decide the clipping level. So according to clipping level, the clippers are classified into positive clippers, negative clippers, double-ended clippers. According to components, diode, transistor, op-amp clippers. According to configuration, series clipper, shunt clipper. According to control of the clipping level, fixed, adjustable, fixed clipper, and according to the external reference voltage, biased, unbiased clipper. So we have, so this is the code. We will discuss about, we are not discussing about any RL circuit, but like we discussed, the RC circuit is capable of integrating and differentiating the signal. RL circuits are capable of integrating and differentiating the signals. But we generally try to avoid the usage of the inductor. That's why we have discussed about the RC circuits. So RL/CCC is the code to remember the classification of the clippers.